everyone, welcome to this episode of Data Epoch. We have Kerry Wheatley here with us today. Kerry is a senior data scientist at Kyndryl Holdings, a spinoff from IBM, where she works on various solutions to enable customers to better manage the cost and complexity of their multi cloud computing ecosystems. She has a decade of experience working in data analytics. She is also very passionate about mentoring other women trying to break into tech. And she also gives back to the community through her work at Statistics Without Borders, which provides pro bono statistical consulting to nonprofit and government organizations. Thank you, Kerry, for being here with us today.
Thank you, Sanjana. I'm glad to be here and to share some of my experiences.
That's great. So, how did you get into data science?
So I actually feel like I fell into the work a little bit accidentally. Uh, I think a lot of people who have been in the industry for a while have expressed the same sentiment. I graduated with a bachelor's degree in industrial engineering from Georgia Tech about 10 years ago. In undergrad, I had limited exposure to computer science and data analytics, so it wasn't really on my radar when I was coming out of school. When I started my career, I knew I wanted to gain a lot of experience and that consulting was one of the best avenues to do that. So I worked in looking for some sort of consulting um, career, and I didn't really know the difference between a business consultant and a technology consultant. I landed as a technology consultant for a software company, and that's when I really started to learn more about data analytics and the power of storytelling through data. I worked as a consultant for 4 years and decided that I had a lot of skills and I was very powerful with data, but I wanted to take the next step through searching, learning from other people's experiences, learning what was out there. I decided that the next step that was best for me was to do a master's in data science. So I actually did that part time for 2 years while working full time, transitioning from a implementation BI consultant into a full fledged data scientist. So after 2 years, I graduated and I have been working as a data scientist for the past 5 years.
Awesome. Can you tell us about an interesting project you worked on?
Yeah. So I can talk about one of the first projects that I did when I joined IBM after completing my master's in data science. I had signed up for the IBM Academy of Technology. That's an internal organization that matches volunteers with internal projects. It was a good outlet for employees who were looking to meet others within IBM and to contribute to projects they wouldn't normally have exposure to. It was a really good place to hone your skills and to test out new tools without having, the deadlines and pressures that might come with your main roles. So I joined a project that was with the Office of the CTO. The project's goal was to create a unified contracts database by combining 9 disparate data silos across various business units. As you know, IBM is a huge global operation, and we have customers across every continent and employees across every continent. So the data silos that they had actually made it very difficult for the business units to learn from each other and to build a common knowledge of their sales pipelines and the contract agreements that they have and had in the past. There was one thing that the contract databases had a lot in common, which was they were all very messy. I think that's very common. Just databases are decay over time. People aren't putting the information that they need into the metadata, and it just becomes very hard to use. So the project wasn't as simple as us importing all the contracts into one database and allowing people to see it. We needed to tag each document with the contract type and then also identify and separate all the other types of documents. There were emails, contact leads, there were screenshots, random one-off conversations, all that was mixed in with the contract data. So the first thing that we did in this project was to OCR the documents. OCR is optical character recognition, and it basically converts a PDF into a workable text file. That was very important for me to be able to analyze the data, was that it was in the form of text rather than an image. After that was done, I was able to start my project, and going into it, I knew that there were two things. One is that this is this is an unsupervised learning problem in NLP. And the second thing is that this was an internal project. So I didn't need to create a perfect 100% accurate model. I just needed to create something that was useful and usable for my project team. The first thing that I did was I tried some common clustering algorithms like k-means, but I found that they weren't very useful in this situation. K-means provides clusters based on a defined number of nodes, so the value of k. But even with a very large k, there was too much variation in the clusters that were created for a human annotator to sort through. So instead, I took a hybrid approach using document similarity and graph theory. I first took each document and converted it into its numeric representation using TF-IDF vectorization. Then I found how similar each document was to every other document in the corpus by using the algorithm of cosine similarity. Both of those are two very common approaches to working with text data. Each document pair was given a score of 0 to 100%, representing how similar those two documents were to each other. And after that, I set an arbitrary threshold of 95% similarity as the only document pairs that I was interested in. So in this corpus, I had identified every single document pair in which there was a lot of similarity. After I got this information, I plugged them into a network graph. In the network graph, I had each node represented one document, and each edge represented a document pair with at least 95% similarity. In this network, I distilled into the individual disconnected graphs. So each disconnected graph here represents a group of similar documents, and this produced the clusters that I was originally looking for. After this, there was a little bit of non-data science engineering cleanup code. In this code, I programmatically sent each of the documents within a cluster into a folder and sorted the folders by size. One folder might contain hundreds of documents, and each of those documents in that folder was very similar to each other in appearance and structure. At this point, that's where I was able to give the product over to our hand annotators, which were the other team members on my project, and they could, within minutes, could tab through all the documents in 10 folders, and each folder they can were able then to tag and mask what the contract type was, just very easily to visually go through their documents. So my model actually ended up being a huge hit with my fellow volunteers who were hand annotating the contracts. And over time, I was able to refine it by changing the vectorization from TF-IDF to account vectorizer. That ended up being more powerful because it took away some of the company names or very specific terms that were being used in contracts. And then I was able to create additional folders with decreasingly similar documents in them. So we would hit the easiest low-hanging fruit documents and then keep working into the more complicated, less common documents.
Noted. That was actually a very detailed and realistic account of, a real world project. So what would you say are some key takeaways and lessons from this project?
So I would say that some things that I learned is that experimentation and creativity is a very important part of data science. There wasn't somewhere where I saw this exact problem and people were able to give me step by step guidelines. So experimentation was key. I tried some approaches at first and they didn't work. And eventually I was able to land on a hybrid approach that was taken from some of the studies that I had and put together to create the solution. I would also say that we didn't need 100% accuracy in this case. We just needed enough to be able to get the project members to acceleration and to speed. So don't always feel like you have to get a perfect result or a perfect model. In a lot of cases, um, trying to get the extra percentage point of accuracy is not worth the amount of investment and resources. And then the third thing I learned is that human feedback is awesome. You can get someone to give you feedback on your model, or even someone to look over your model or talk to your model about that gives you a lot of power in being able to come up with a solution, and it gives you a lot of acceleration to get to the solution that people can use.
Very cool. And did you get chances to like tap into these learnings or reapply them at other stages in your career?
So that actually, for this case, I was able to apply the same approach for two different projects for two different organizations. When the COVID pandemic started in early 2022, I volunteered for a project with Statistics Without Borders. The project was done for the Montgomery County MD Virtual Emergency Response Team. They approached Statistics Without Borders with a question. They wanted to know if they could use Twitter data to identify whether there was more conversation about COVID within certain areas of the country. This was during a time when COVID was very new and there was very little information about it. And they were just trying different ways in order to understand how COVID was spreading within different areas. So the project that we started with SWB, Statistics Without Borders, was to label tweets as relevant or not relevant for COVID in order for the team to then use in downstream analysis. I applied a similar approach here where I clustered the tweets by topic similarity using the document similarity and network graph instead of doing the TF, IDF, or count vectorization. I used word embeddings to try to see if I could capture more of the synonyms. One of the problems with Twitter is that it's a very short form of conversation, and a lot of times there are acronyms. They use a lot of smileys. It's just a harder um, like text to use. Overall, the clustering provided some results that are human annotators. I love human annotators. They're just, very helpful. Um, that I was able to create clusters for them to annotate more quickly. But overall, the results were not as strong as when you have predefined contracts. Um, so it was really cool to be able to see a different problem that could use the same solution. And I was also able to get to speed there because I already had experience working with this type of problem. I was also able to use the same approach later when I worked on a project at IBM. I was working on the multi cloud management platform team, and this project ended up becoming a new product offering. And I also filed two patents for the work. Now, the overall solution was much bigger than what I described in my previous project, but a lot of the learnings that I gained from that project was used in this one as well. So, the core of this project was to categorize different key value pairs as being the same information. In cloud computing, there's the concept of key value pair tags that are attached to different assets. So one example of a key value pair would be an environment tag that has production or development or testing on it. The problem with these tags is sitting in the environment is that there are no constraints on it. So there could be spelling mistakes, syntactical errors, abbreviations. For one tag, I've seen environment. I've seen environment spelled incorrectly many different ways. I've seen production attached to it that's also spelled incorrectly many different ways. I've seen it abbreviated. And what happens when we try to do BI reporting on that or governance reporting is that like environment production spelled incorrectly does not match with another version of it that's spelled correctly. In that way, we can't do proper reporting on it. So in this project, what I ended up doing was to create a system to match the environment tag with its intended environment tag to create a primary and subordinate group. The primary would be the correctly spelled environment tag, and the subordinate would be the incorrectly spelled one that might have been incorrectly spelled 5 different ways. This approach, I took the same solution from previously where I created a document similarity and also a network graph to cluster the tags together. In this case, instead of using TF-IDF vectorization, count vectorizer, or even the word embeddings, I used instead a fuzzy matching algorithm called the Levenstein distance. Levenstein distance is used to determine how closely one word relates to another, based on how many substitutions or deletions or insertions it takes to convert one word into another. So if I had production and I was comparing it to the word production that had, for some reason, an extra E at the end, that would be a very similar word because it only takes one deletion to get from one word to the other. In that case, I was able to take the approaches of the similarity scoring and then also the network graph. But in every one of these projects, I tweaked it a little bit in order to be able to use it for that use case.
Awesome. That's pretty inspiring that you can learn something once and apply it in multiple places and even lead to patents. So, do you have any advice for our viewers or listeners to keep upskilling in data science?
For me, it's been very helpful to find small projects and side projects to do. There are a lot of them out there for data scientists. I've done the IBM Call for Code, which is a open to the public, uh, and it's a competition where you can do something good for the world. There's different themes that might be environmental based or health based or other um, like categories of things that we could do. There's also the Women in Data Science conference always has some different competitions for it. There are hackathons that are available, Kaggle competitions, and statistics web porters, which I mentioned. So I think that there are a lot of ways that you can just work on weekend projects, and these don't even have to be that long. They could be one day's worth of work, and you still gain a lot from them. Uh, Something that I think is also very useful is when you do a project, maybe jot some things down, post it on towards data science or post it on your GitHub page and just kind of let it out there and let other people see what you've been doing. And that encourages other people to, um, you know, look at your work and talk to you about it. There's a lot of collaboration online. I know that there's a lot of people that are interested in collaborating. And I think that's one thing that has helped me is having other people reach out to me and ask me if they want to, if we want to be on the same project and work on something on the side. And then you kind of get to share your results with other people.
Awesome. So thank you, Gary. This has been great information and great inspiration. I'm sure everyone
Thank you, Sandana.